Uh, Good morning to you all. I think we shall start, right? Because the thing is now not like last days. Today we don't have time. Now today we are going to study a little bit of civil 3D, and it's a big software as I told you. So big in the sense, of course, you will have to work hard to master this program, right? Uh, now the thing is Civil 3D is a design software, so that you have to understand that, right? So, what do you mean by a design software, right? So, you can get its help or assistance to do the uh, design. But the problem is now, as a design engineer, of course, you will have to do your own design. It does not design for you. That you have to understand in the beginning, right? So why do I say like that? Sometimes there are some software that it does design for you, right? So that means it does the analysis part. And of course now just think about some structural software. So you have to give like the loads and things. Then it gives the number of reinforcement bars that you have to use, right? But here civil 3D is different. Okay, it does not give you, that means it does not design for you. The design is your sole responsibility. Okay, sole responsibility of the design engineer, but it does some calculations for you and it draws something for you, right? So that is what the civil 3D is doing, right? So that is what you have to understand, and we should be very happy about this. Why? Otherwise we are going to lose our jobs. Okay, so do you know now today's now in today's context we have drone surveys. Now you know how you did that, some say 20 years back. Some 20 years back how you did it was using a helicopter and a camera, right? So then now, once we get the drone service, the pilot lost the job and the cameraman lost the job, right? So now it is fully automated. But thankfully, design is not like that, and I don't see in foreseeable future the designers will lose their job, right? Why? Because maybe if you want to do a design by a machine like computer or something, maybe you will have to go a long way along AI, artificial intelligence, and it is not there in our foreseeable future. So we have to be very happy about it, right? As engineers. But the thing is, now when it comes to civil 3D, what we are basically doing is we model our 3D rod in the software itself. After that, on top of that, we are trying to do our what? We are trying to do our design, right? So now in last lectures, I told you. Now you know there is something called. Now the thing is that rod is a 3D object. What we do is we uh, project that into two planes, one to horizontal, other to vertical, right? So that is exactly what we do using this civil 3D software, right? So now I have prepared a presentation. Maybe you have got the printouts, but I am not going to show that presentation now. And again, I have sent you a small booklet. Now please share this among you. Now those who are interested, why? Because it has everything that you want to know about civil 3D, and step by step that I have described how you are going to use the civil 3D software, right? So that will be very easy for you, so you can do self study. In the university setup actually we do not have lot of time, so I am only given 4 hours. If I am going to do this for a private party or something, usually I take 16 hours. That's the minimum for a design engineer. And there are some other now there are some places where you can follow this course that will be like 6 months or 1 year. But you need not to follow these things, of course. Now you get the basic introduction to the software using my now with my today's lecture, and after that you can follow my book, and I'll give you the links to my presentations and the videos and things. Usually I share them among all the university community, so you can share the knowledge and you can do it yourself. Okay, so we'll start, right? Right, now the first thing, now I'll show you what I have given you, right? Now there is one thing, that is Civil 3D guide. I'll just show you. Now of course this is the booklet I described, right? This is the booklet I described. You know, here everything is there. Okay, from introduction to how to do the surface creation. You know, surface creation in the sense that is 3D modeling, right? And theory parts are also there, and how you are going to do the horizontal alignment, and how you design compound curves, how you design reverse curves, and then the transition curves, right? And how to enter super elevation, right? And vertical alignment. Now please understand, now when it comes to vertical alignment, there is something called offset method. You know what is this offset method? The thing is, at the at the very beginning, right? At the very beginning, what we have now, the data set we are having is using total station, right? So the problem with the total station is, their levels are not that accurate. But please understand, accuracy is different in highway engineering. When it comes to structural engineering, accuracy may be say 1 millimeter or 2 millimeter, something of the sort. But when it comes to roads, we don't have that much of accuracy. Maybe 5 millimeter is enough or 10 millimeter is enough. Okay, can be. Now the thing is, now the first data set that I have given is has been taken using total station. But when it comes to vertical alignment, sometimes we have to get the levels using the leveling instrument, right? So that is why using the offset method is that there is a method that we have to use this level instrument data for the design, for the vertical design. So why there is a difference? How do you take total station levels? You take in the format of X, Y, Z. So the leveling instrument, how do you take? In the leveling instruments on the roads, maybe you don't know. If you have if you are not familiar with the road construction, there what we do is we mark the chain edges 0, 10, 20, 30, like that, and perpendicular to these chain edges, I mean to the center line, we take levels. So there is something called say offset, right? -1, that means from the center line perpendicular to the center line, LHS side. How do I know LHS side? Because it is minus 1 meter away. So that's the level. Say you get plus 0.53. That is, so maybe there is a chain edge like say 100. From that chain edge perpendicular to the center line, 0.53 towards right side. Okay, so that is how do you take uh, this leveling instrument levels, right? So that is why we want to have another surface or another 3D model using level instrument data, right? Then there is existing profile and the recampering profile. I'll discuss when I go there. Otherwise what happens is, if I am going to discuss everything, you will not understand anything, right? So then drawing sheet generation, design cross section, material calculation, and in this version of the book, I have included an annex for you to understand the superelevation calculation. So you have understood you have learned superelevation calculation in my lecture, but I haven't described all the details on how you are going to calculate in the field. Simple curve, reverse curve, closed space reverse curve, compound curves, and closed space compound curves. Now in the book, everything is there and you can read and understand. Okay, and I am not going to cover this whole book, I don't have time, but we'll try to cover as much as possible, right? So then I believe that you have a student version of Civil 3D software. So maybe you can use for 1 month for free. Right after that, if you are going to buy a license for 1 year, it may be somewhere around 6 lakhs or 7 lakhs or something like that. For 3 year license is definitely 2 million rupees. So it's an expensive software, but still you can get the student version for your education. So that means there is a time restriction within 1 month. That is how the situation was at that time, right? I don't know, you check. uh, Student version is valid for 1 month, so within 1 month you have to finish everything, right? Sorry. So now I'll describe what I have given you, right? So now last day, maybe day before yesterday, I sent Mr. Vasantha. Okay, day before yesterday, I sent Mr. Vasantha some example drawing and an example data sheet, data set. Also, I sent you what a template, right? So you have to have these three things in your computer to start our lesson today. And also you have to have Civil 3D student version installed in your computer, right? Now if you don't have that, don't worry, just look, and just think that you are I don't know, if you are in a boarding place or something, so that you are doing this with friends or something. So the best thing is you have my video in one laptop and you guys get together and try to do what I am showing you in the other computer. So that's the best method for software. So because this is not just a lecture, this is of course a workshop like. So you should know how you are going to do that, right? Now I am going to start today's workshop, right? The first thing that you have to do is you have to open, you have to you have to launch Civil 3D software. So if the Civil 3D software is installed in your computer, if you are going to launch it, always try to launch Civil 3D metric. So I'll show you. It's not showing. Yeah, great. Right, I think you can see uh, what is in my desktop. I mean in the screen, this is, I have the 2018 version. uh, you know uh, so it can be, say, maybe you are having 2020 version, 21 version, 22 version, or you are having 2016 version, whatever, it's okay. After 2015, if you are having a version, then that is perfectly okay, right? So I just opened it, right? Now the first thing that you have to check is, please check whether you have this one. What is this menu bar? and you have to make sure here you are having civil 3D. Now if I drop down it, it can be civil 3D, drafting annotation, 3D modeling, planning and analysis, or something like that. It should be civil 3D, right? And right hand side of this there is another drop down box. See, if I want, now only you are seeing, right? So what I was telling was, here the workspace it should be civil 3D. If I drop down it, there are some other things as well. Now just think that if I go to 3D modeling, it's going to change, the working environment is going to change, right? So if I am having civil 3D, again it's going to change, right? And then right hand side of this workspace, here you have another drop down box where you can either tick or untick this show menu bar. Now just think, if I untick show menu bar, what will happen? I'll show hide menu bar. Here that file and things are not there. Now if I go and click show menu bar, here file, edit, view and everything is there. Now the command should be there. Otherwise, as I remember, it is control F8 or something, the command will come. Now let's check control F8. No, not control F7. No, F6. F6 gone. Anyway, don't worry, you can again start, right? Right. Then the first thing that you have to do is you have to have your own template. What do you mean by a template? Right? Now, please understand, usually any road agency or any highway design company, they have their own format. Some people call it chainage, some people call it station. Some people give the chainage as say 0 plus 0 0 0. Some people give just 0, right? Different road agencies give different, now it is kind of a presentation technique. Now the problem is, when it comes to different presentation methods, you have to have a consistency for one road agency. As an example, if you are having your own company, on the first day you can't have, in one drawing set you can't have the name chainage, and on the other drawing set you can't have the name station. There should be a consistency. And if you are going to give the chainage as 0.0, sorry, 0 plus 0 0 0 in one drawing set, and on the other drawing set if you are going to give the chainage as 0 only, so it is going to be very bad professional practice. So what we do is we are trying to have our consistency with them. Okay, so for that we prepare a template. Now if you don't understand this, just think about Word. In Word also, in MS Word also, you have template. So maybe in that template, your font is Times New Roman and your letter size is 12. So they are already set. Everywhere you load that, what happens? So the same settings are coming. So that is why we have made a template. So I have a template that I have made for some other universities, but we'll use that because there's no point. What I have to do is change that name into your university's name. If you want, you can change it, right? So the same thing. So we load that. How we are going to do that? Here, uh, this is that template. So you have to copy it, right click and copy. Okay, you have to right click and copy it, right? Then you go back to your civil 3D and then you get file, new, you go to file, new, and there comes a select template dialog box. Here we'll create, right click, we'll create a new folder, say usjp, right? Then you open that, and there you can right click and paste your template. Okay, then you select it and open it. This is just an error message because the template was created with an earlier version. It doesn't matter, you just close it. And this is also coming everywhere because that we have not installed VBA. It doesn't matter, continue with current command. Okay, right? Now you might see there is one thing drawing one, this other one drawing two, right? The thing is drawing one is the default template, drawing two is our template. Now it is selected, so you can shift, say drawing one, drawing two. Drawing one is the default template, we don't want it, we'll close it. Save changes to drawing one, no. So drawing two is our our template. So the very first thing that you have to do is you have to save your drawing in your folder. We'll save it, file, save as. So we'll go to our folder, and I'll save it giving the name surface, right? Now please understand, I am not going to follow that book or whatever, that presentation or whatever. Everything is there. You can later read. But what I am trying to do is I am doing what is necessary. And that is there in my presentation and in the book. So the thing is actually I'm going to record this one and I'm going to upload. So if you have any problem, of course, you can later refer. So don't worry. If you have the software, please try to do what I am doing. Okay, that's all. If you are going to miss something, don't worry, we'll correct them, right? So now you know your surface is, yeah, your surface is being created. Surface in the surface file is created, right? So I will open my topographic survey file to see what is there. File, open. So here example topo 2, I'll open it. Now you know what is that, right? This is a topographic survey of a road. This is a topographic survey of a road. So what you can see there. Now there is a bridge here. What is this yellow line? This is, this is the towage line. That means the existing towage, right? What is this yellow line? That is the existing what? Existing towage RHS side. Then what is this red color one? That is the existing center line. So what are these things? This is a point. These points were created. I mean, the file was created using some surveying software. Okay, creating some surveying software, and here we have the point. Here is the point, and this is the elevation, and this is the point number. Okay, so, and what else we have? We have the topographic survey. Here garage, WF means wired fence, GP means maybe gate post or whatever. They have to give a legacy. Okay, and some they have mark. Claimant is not known. Claimant means the owner, right? So here there is this Samavata, and then Nilhani Motors, Nilhani stores. Like that, everything is given. So what are these things? These are the these are the total station points that they have used, right? So they have run a survey topographic survey, and this is now these are the points that they have taken. We want these points, so maybe these are some permanent stations or something. We want these points to set back our road once we complete the design. Okay. Now there is another thing they have given. I'll show you. Here I open that notepad file. Right here, these are just data. These are just data. Okay. Now can you see here that survey has given us the data format PNEZCD data. What do you mean by P? P is point number. So please note down, right? P is point number, N is northing, so that is the northing coordinate. E is easting, so this is the easting coordinate, and PNE, this is northing, this is easting, Z is elevation 49.272, and CD, I don't know what do you mean by C, but it is it should be D only, right? D is description, NB like that. So that's all what we have got. We have got the file, topographic survey file, and we have the data set. That's all we are having for the time being, right? Now I'll close it. Right. Now since we have our data set in a separate file, in separate file in a notepad, we don't want to have these points showing. So we'll switch off the layers. So select this one and check it is height. So you can switch off the layer or freeze. Right? Then what is this one? That is number. We can freeze that as well. So what is this one? That is code. So you can freeze that as well. And this is the point. You can freeze that as well. So once you freeze these things, everything is gone. So that means everything is vanished, right? So now I am going to import my data set to this topographic survey file. Remember, this is not just the topographic survey. We will have to copy this into our template. Okay, how you are going to copy it? Now there are two files. Can you see? One is surface, other one is example topo 2. Surface is the file that we created using our template. Example topo 2 is the one that survey gave us, right? So I'm going to copy this. When you select them, please understand you have to select both to select everything, right? Top to down, down to top. Edit. How you are going to copy? It should be just copy, right? So the cursor came back. Then we will shift into surface, and here why is there? Because I have gone to a layout. So you go back to model, right? Then edit. Remember, don't just paste to original coordinates. That there is a difference between your structural drawings and highway design drawings. If it is structural drawing, you don't have a coordinate. Okay, so you can paste it anywhere you want. But when it comes to uh, what you call the highway drawings, we always work with a coordinate system. Either it can be national coordinate system or global coordinate system or a local coordinate system or whatever, right? So usually we go to paste original coordinates. So that means the drawing comes to the original coordinates which was done in survey's drawing. Okay. paste to original coordinates. Now here this is that one. If you don't see it, okay, just think it's somewhere there. You can always try Z enter, E enter, that is zoom to extend, right? Now this is our survey drawing copied to our template, right? So you can save the drawing. And there are some good practices in civil 3D. One is to switch off all unnecessary files, right? So now we have this surface, we don't want this example topo 2 because we copied everything from there. Now you can switch off it. Save changes? No, don't save because that is the surface drawing. We are not going to change anything there, right? Now I am going to import my data set to this file. Okay, I am going to import data set to my file. So here can you see there is something called points, the drop down box, you drop down it and there comes point creation tools. Okay, you drop down the points and there comes point creation tools, right? Then there comes a a toolbar. Okay, there comes a toolbar. So how do we do that? Points, point creation tools, right? Points, point creation tools, and then you can have this point creation tool bar, right? Then here there's a tool bit called import points. Okay, import points, right? Click that and there comes the dialog box import points. So here specify point file format. So do you remember the point file format? PNEZCD, but it should be, I told you it should be PNEZD. So you select that data format from here, P PNE PNEZD space limited comma delimited, space delimited comma delimited. What is the difference? Do you remember? Now I'll show you, right? Now do you remember here in our text file, it is separated by commas, not space. One comma, there is northern coordinates, comma, eastern coordinates, comma, and the elevation, comma, something like that. Okay, so that means it is comma delimited, not space delimited. If it was space delimited, there should be only a space, not a comma. So you have to select comma delimited format, right? So here you have to select PNEZ comma delimited. PNEZ comma delimited, right? Here selected files. So it takes some time to show, isn't it? So you have to select here PNEZ comma delimited. And here from this plus mark you have to browse into your file. Now please pay your attention carefully for these things that I am telling. Now this is one such thing. You have to make sure that your notepad file is closed once you do this. Why? Otherwise there will be a sharing violation. Why? You can't use the same file in two programs, one in notepad, other in civil 3D. Okay, so what you have to do is you have to close the notepad if you have opened it to check something, right? Now the notepad file is closed, right? So now we'll add and we'll go to our folder. There's nothing, right? Why? If you check files of type, it is CSV. That's a different type. Okay, so you can have dot text. Then it shows PNEZCD data text. Select it and open it. Now this is how there's a sample how they are coming. There comes the point number, then comes the northing, then comes the easting, and then comes the point elevation, and then the row description. Right? So you check this add points to point group and create a point group. What is that? We'll give topo. Right? We'll give topo. Then press OK. So you don't check this, do elevation adjustment if possible or do coordinate transformation if possible. There are some advanced options. If they are checked, you have to uncheck them and then press OK. And check what will happen is that the data set will be imported to this file. It will take a little time, right? Depending on the capacity of the data set. Now this is a regular error message. Don't worry. You click this. Now you can see here, these are the data that you have imported. Now you can close this toolbar because whatever that we want to get it from there is finished. Now you can see here, this is the point, this is the point number, and this is the elevation, and this is the point description. Okay, can you see? And again, I invite you to observe some very crucial things in this file. What are they? One thing is, this is our existing center line. Now you can see the data has been taken exactly on the existing center line. Actually, what has happened is not that they have taken the data on the exact existing center line. What they have done is they have taken the points and then they have drawn the existing center line connecting each of them. It's same for tar edges, LHS and RHS. Okay, now this is finished. We have we have imported all the points into our uh, file, right? Now, before proceeding, do you have any questions? Now, please understand that you are having a very big privilege to study this software, right? So, get the maximum use of it. We have only 4 hours. Please ask me questions if you have any. Right, no questions as usual. Right, so then we'll proceed. Now I am going to create the surface. What do you mean by a surface? Surface means I am going to 3D model this road. Now you know this road is in 2D. Now I have imported because whatever you draw in Civil 3D or AutoCAD is in 2D, right? Okay, unless you have gone for some 3D design. So I mean the 3D modeling. Now we are going to 3D model. Up to that it is 2D, right? So what I'm going to do is I'm going to create the surface. So once I create the surface, I'll describe what do you mean by a surface, right? So now you know there is something called tool space. If it is not there, you can conveniently take it from say general tool space. Okay. So if it is gone, you can get it like general tool space, right? Then you know there are many tabs here: prospector, settings, survey, and toolbox. So all are having different options. So you have to come to this prospector, right? Now in the prospector, you can see there is something called surface. Why? Because that file name is surface. And then there we have points. If you click it here, it shows the points that you have imported. And there is called point groups. You know, it is called topo. It's showing. And then surfaces, alignments, there is nothing, right? Surfaces, you know, it doesn't show anything because we haven't created a surface. Surface is the 3D model, right? So I'm going to create one. How? I select the surfaces and right click and press create surface. Okay, create surface. And then you have to change only this thing. Name, you give it as EG, that is existing ground. And the style you can give here. Just check how I'm going there. Now it's nothing like, okay. And then I'll select this one, and here contours, I'll go for contours, points and triangles and borders. Okay, then press OK. Right, then press OK. Now if you immediately come here, you will see that the surfaces has become a, you know, a drop down box here. Drop down, no, not a drop down box. If you expand it, then there is a surface called EG. Now did you see any difference here? No, not so far, right? So you expand this EG, then there is mass, watersheds and definition. You can expand this definition as well here, and then you can see point groups. You select it, then right click and press add. Here this is the point group that we created, topo. Press apply and press OK. Now you can close this. Here this is our surface. Okay, now please pay attention on our surface. Now look what they have done, right? Look what they have done. You know these are the points that we imported, and what they have done is they have drawn lines connecting each other. Now here our level is 36.892 and here the level is 36.819. Remember the levels, right? Now if I check somewhere in between, you will see you are getting some elevation value at the very bottom, right? Elevation 36.825. So what this software is doing is that it interpolates the levels in between. So higher the number of levels that you have taken, higher it is going to be, the accuracy is going to be higher. Understood? But usually we don't take levels everywhere. We are taking in some important points, right? Like edge, right? And then the center line. But remember, now I'm going to tell you or teach you one important. I will save this first. Now I'm going to show you one important concept. Now just think this is a software, right? So that means it's a robot. Okay, so it doesn't have a brain. Okay, it doesn't know anything about highway design. What it does is what we ask it to do. Now just think, I'm going to draw our, okay, I am just going to draw a road, a road cross section, a cross section of our road like this. Just think. Just think this is our road. And I am selecting just some, some random layers, right? I'm just drawing some random layers. Why? Because I'm going to explain you something, right? This is the tie LHS, and this is the center line. This is the tie RHS. Okay, this is your rod cross section. This is LHS tie center existing center line. This is what? This is tie RHS, right? Now you know surveyor. Okay, surveyor, he has taken these points in our cross section. Just think this one. Oh, and this one, and this one, and this one, and he has forgotten to take this center line. And he has taken, sorry, and he has forgotten to take this point also. He has taken this point, right? And he has taken this point also. Now I ask the civil 3D to draw this cross section like this. How does it draw? How it draws is like this. There is a point. I come here. There's another point. I come here. Another point. I come here. Another point. I come here. There's no such point there. I'm going here. There's no such point there. I'm going here. Then there's another point. I come here. Now the yellow color one is the actual cross section of the rod, and this is how the civil 3D draws it if the survey has not taken or he has forgotten to take these points. Therefore we have a small tactic. Okay, we as designers have a small tactic. We give, right, we give an instruction to software saying you have to you have to connect these 3 points definitely: LHS tie, RHS tie, and LHS tie, RHS tie, and existing center line tie. So we give that instruction. Okay, we give that instruction. Definitely we have to connect this point. Sorry. Then how does the software draw it? Then it will try to draw it like this. I'm coming here, there's a point. I'm coming here, there's a point. I'm coming here, there's a point. Then I am trying to go there, but there is an instruction. Definitely you have to connect this point. There I am coming here, there I am coming here, and here what happens? There is no such instruction to take this point, so it will go like this. So this, now if you just think, this yellow color one is the actual cross section. Blue color one. Blue color one is the cross section that the Civil 3D has now drawn. Okay, because we haven't given that other instruction so far, right? So this is the one that we have, that the Civil 3D has drawn so far. Now we are going to give an instruction. Definitely you have to connect these 3 points. So once that instruction is given, this is the cross section it's going to draw. This is how it is going to model, right? Is this the most accurate one? No. Why? Because this is not connected. But still, as far as our road is concerned, it is fairly okay. Now we are worried about our road mostly, not the widening sections. Okay, so this is exactly what I am going to do. I am going to give an instruction to the software saying definitely you have to connect this point, and this point. Okay, So for that, there is a tool in Civil 3D calling what? Break lines, right? So I'm going to delete this cross section drawing. So I have to give, now you can see, I'll show you, right? Here, can you see? This is the tie RHS one. Okay. Now, can you see that some lines have drawn cutting that tie? Can you do that? You can't do that. Why? Definitely, this line has to be disappeared, and only you can't cut it, because now you might have understood with my elaboration, right? You can't cut it. And can you cut the center line? No, you can't. But in some places it has cut center line also, because we haven't given the instruction that these three should be break lines. That means you have to break your model in there. Okay, right. Now we'll give that instruction. How you are going to do that? You go to general tool space. If it is already there, don't do anything. Huh? So there is this expansion here, and you go to break lines, then right click, add, and give the description as TE, just type should be proximity, and then press OK, and then it says select objects. So you select this edge and you select this edge. Now pay attention, once I press enter, these lines that cut edges will be vanish. Press enter, right? Now it is no more. Now I have to draw, I have to give another break line, that is the existing center line. Okay, so here you can see this is the existing center line, they have cut it. Now I am going to add this center line as a break line, and these two lines will be gone. Break line, right click, add, give the CL, type is proximity, and press OK, and select objects, this red line, that is center line. Press enter. Can you see now it's gone? Save the drawing. Right. Now there is an obvious error in this surface. What is that? Now I told you how the Civil 3D models, the terrain is by drawing lines connecting each of the what? Each of the points. But now just think here, there is one line starting from here and it is coming there. He has taken some there. Now everywhere in between, the software is trying to interpolate the levels. Is that correct? That's wrong, obviously. Now if you just think here, there's one point here at this part of the road, and there's another point there at the other part of the road, and they have connected these two, and they are interpolating in between, because we know nothing about this area. We haven't taken level, so this is obviously wrong. Okay, now here also see one point here, another point there, and they are interpolating. So we have to show our limits. This is all you have to go, right? So what we usually do is we add a boundary for that. So before drawing the boundary, make sure that your O snap is off, F3, right? Then this is, a polyline. So you draw a polyline. It's like this. So select your boundary. This should be our boundary. Once you come here, you press C and enter. So the polyline closes the boundary here. This is our boundary. So we can add that boundary also. Now once we add that, please understand these lines will be gone. So there is something called boundaries. You select it, right click it, add, and press and type BD. Type is outer, untick is non-destructive break lines, and mid ordinate distance you have to give as 0.001. These are some conventions, right? Press OK, and then they say select objects. Once you select this object, you will see the lines beyond that one will be gone. Okay, so I'll select this one and press right, already gone. Now this is our surface. Now this surface is perfect, at least up to the accuracy given by the Civil 3D software. Okay, right, save the drawing. And there is another thing that we are going to do. What is that? There's another thing we are going to do. We are going to export this into XML format. So what do you mean by XML format? XML is a text format. So you know this is kind of it is a CV3D format. We are going to export this into a text format. So the advantage is, you created this surface in Sri Lanka. Maybe you can export, you can email that into America or Australia without any problem, because you are going to reduce the capacity of the file. So have you studied some IT? If you have studied some IT, maybe you know what does a web browser do. Okay, now do you think that all the settings of your web page and the pictures and everything, so and the letter sizes and then the colors and everything, do you think that everything is coming from America? No, it doesn't take anything from anything, in the sense it just takes some what is the language that computer understand? It understands only one language. What is that? Binary also, it doesn't understand 1 and 0. It understands only one thing. What is that? Whether there is electricity or whether there is no electricity. That is, if there is electricity it is 1, if there is no electricity it is 0. That is all it understands. That's the only signal it understands. So, in internet technology, what they do is, so you create the web page, and then through the internet, what you send is only 101010. So once it comes to Sri Lanka, you have something called web browser. So it interprets everything, right? So then actually what you see in your web page, in your web browser, is interpreted by itself in Sri Lanka in your own computer. So the same thing what we are going to do is here in XML, right? So we convert everything into text format, and then we are going to send it to somebody. And in Civil 3D, so you send, just think that you sent it to me XML, and now I am going to interpret your XML file in my AutoCAD software. So it interprets nicely. I'll show you, right? So we'll first export this into XML format. You select this EG here, surfaces, under that EG, you right click it, export to land XML. Here you can see only EG is ticked. So you press OK, and then you go to your folder and then save surface. Now our first part is finished. You can save the drawing and close it. Now if I go to this folder, you can see another file created, surface XML. I'll open it and show you. Now this is that XML. Now you can see they have defined the boundary. These are the the coordinates, and they have defined the break lines. There should be three or two because we created two. This is TE. Yeah, there's another one TE, and this is CL. So they have defined the break lines also, and after that these are points. Okay, they have defined the points also. So everything is there. Now you can see how many points, the hell of a number of points, right? Okay, so everything is there. Now only thing is that you can interpolate it, sorry, you can interpret it, right? Now again open Civil 3D software. Right, I have opened Civil 3D software. Now I am going to load my template. Now do I have to copy and paste it again? Because no, because template is already there. Here file, new, and here a folder is there. This is our file. You open it, press close, continue with the current command, and then you can save it as, go to your folder, and you can save it as say alignment, right? Alignment. Now this drawing one is the one with the default template. You can switch off it, right? Now again open our surface drawing file, new, sorry, file, open. This is example topo 2 drawing. You open it. Now this is the survey's original drawing. Now you know, again you have to do these corrections, that what you did. You have to switch off these things or freeze, number also, and then height also, and this point we'll see point. Right, now select everything, edit, copy, copied, go to alignment, edit, paste to original coordinates. Here, now you close that example topo 2 and save this alignment. Now even though you call it alignment, nothing we have done. We have only copied the surface drawing from the surface drawing, right? Now we can import our surface that we created. How we are going to do that? File, import, import land XML. Now you go and select surface and press open. Here also press OK. Now you can see your surface is imported. If you have any doubt whether this is the same surface, what you can do is you can select this surface, you go to surface properties, and here surface style should be, you remember contour points and triangles and borders. Press apply and press OK. Now this is the same surface that we created. Save the drawing. Now you know when we are going to do the alignment, of course, we don't want to see these details. So what we are going to do is we are going to switch off the surface. Now you will ask me why, if you are going to switch off it, why did you create it at the first place? That I will explain you in the middle, right? Why we created this, right? Now you select this one, right click. Don't delete, right? If you delete, it's gone. Okay, so what you are going to do is you go to surface properties and then surface style we are going to put it to no display, right? Then still there are some three lines. We'll see what are they. This line is EG break lines. So you can switch off it, right? Now this is our rod and we are going to put the alignment, right? Now before before trying to design the alignment, before trying to design the alignment, you have to do something. What is that? You should know the theory behind it, right? What is that theory? Give me a second. I'll show you. I'm going to show you some notes, right? That you already have. This one you have like presentation, of course. So I'm going to show you a table. That table you have, right? Here. This is the table I want. You know. So what is your design speed? You have to know that, right? Your design speed is 50. Let's say. Then you know your minimum curve, your super elevation maximum. Just think that this is in flat terrain. So the maximum super elevation you can give is 4%, right? So your curve radius should be 95. So better if you can go above 105. So that you have to keep in mind. Your minimum radius is 95 and it is better if you can go beyond 105. Also, if you cannot design for 50, maybe you can go for 40. So your minimum curve radius should be 55, right? So you have to take all, you have to put all your effort to improve that into at least to 55-meter radius. 95 is better. We'll see. Okay, right. Now, please pay attention. I am going to design, right? I am going to design. Please pay attention. Now usually, now you know this is an existing road, right? So we are going to improve that. So for that, what we really do is we have to follow the existing set line as much as possible. Now you know there is a bridge. Of course, you can't do anything with that. Before designing, you should know what is your cross section. Now, the cross section of the the design road. So I'll take this as two-lane highway. Okay, I'll take this as two-lane highway. right? So you know it is a two-lane highway, and our cross section should be say lane width is 3.5. So both way from the center line there are 3.5, 3.5, and then you know there is a hard shoulder. We'll take it as 1.5, right? And the soft shoulder, we'll take it as 2 meter, right? So that is our cross section. Please note down our the cross section would be like this: 3.5, that is lane. So there are two 3.5s both side of the center line, and then 1.5 hard shoulder both sides again, and then 2 meter soft shoulder, right? Right. Now this is a bridge, so you cannot change our center line here, so we'll have to have a line like this. Okay, now let's design this alignment. For that, you go to this menu, and here alignments, take create alignment by layout. Then there comes create alignment layout dialog box. So you give the name as DCL. This type should be center line, starting station should be 0, and there's no site. If you want, you can, here there's one site called site 1, otherwise you can create one here. Just think that you want site design. Okay, then alignment style you go for UOM, and alignment label set you go for UOM, right? Here these are, of course, just some templates. So if you want, you can change them, right? Say edit current selection. So if you want to change that name, you can change. It comes there, right? So if you want to say edit current selection, so if you want to change these things, you can change here display. If you want to change a color or something, you can do it quickly. Okay, it doesn't matter, right? So you press OK, and then there comes alignment layout tools. Okay, and then here we are going to design. Here you can see it should be a line, right? So usually we start our alignment either with the what? We are going to start our alignment either with a fixed line or a fixed curve depending on the road geometry. So here it should be a line, so we will select fixed line, 2 points. Okay, so I'll select here, and you know I'll go this way. So you have to make it as much as possible to close to the existing center line, right? I entered, and now I press enter. Now you can see here it is being designed up to here. The station, now you know this green color one is the major stations, 0, 20, 40, right? And here this blue color one is the minor stations, right? Now here, right? Here there is a, this is a curve, or these are some two compound curves. Can you see? With the practice you will see that it's either curve or two compound curve. So what is our minimum one? 95. Minimum radius 95. Okay, so we'll try 95 here. So I'll go here, floating curves, right? Floating curve from entity radius 2 point. So I'll select that, and it says select entity to attach to. So this is the attaching entity. Specify radius. So I'll go for say 120. I'll try that. This is a trial and error method, right? Because you cannot look at a existing set line and say what is the What's it? What it's the uh, radius. You have to trial. You have to do trial and error, right? So we will select say 120. Press enter. Is curve solution angle greater than or lesser than? So I don't understand why they ask this question. What does this ask? Now when two lines intersects. Okay, when two lines intersect, there are two angles that emerge. One is lesser than 180, the other one is greater than 180. Now, usually when it comes to roads, it is always lesser than 180. Understood? Understand what I'm telling? Now when two lines intersect, there are two angles. One is lesser than 180, the other side of that is greater than 180. So usually always we use that lesser than 180. So it is what is selected. You press OK. Specify endpoint. So I am going to now what happens? Look how it comes. Can I go for 180? 120? No, you can't. Here now this is the bridge and it's coming like this. So it's not possible at all. I press escape. So what was our minimum one? 95. We'll try that. Plotting curve. I selected this. Say I'm going to give the radius 95, lesser than 180. If I put 95, this is how it is coming. That is also not going to work. Press escape. Right. So I'll have to go and select, go and refer my table. Very unfortunate, right? Why? At the very instance that we are going to start it, we cannot select the I haven't shared. Now maybe I'll have to try this one 40. So the minimum radius I can go is 55. We'll see. Right, we'll select plotting curve and we'll select entity and we'll give, what was that, 55? Yeah, 55, lesser than 180. Now this is how the 55 comes. So it seems it is fairly okay. Can you see? But it improves the road. If your bridge is going to finish from here, then only you can have a curve like this. Okay, so your curve should not come into the bridge. These are the things that you have to check, right? Because you can design it and give, but they cannot construct it because the bridge is finished here. So only after that you can start your curve. Now it's okay. Now just think, there it seems like a straight. So for that you are selecting floating line. Select entity attached to this one. So I'm coming like this. You have to match it as much as possible to the existing center line, right? Now maybe if you want to change it a bit, you can change it like this, right? And then what about this curve? There are two curves. Can you see? One curve is like this, the other curve is like this. There are two curves. It is not just one curve. If you want, you can check it. How? So you go to this home and here these are arcs. So you can get the start, end and direction. This is not Civil 3D, yeah? This is AutoCAD. You select the start point, say this is the end point, try to fix a curve like this. Ouch. It already fixed. You have to get this start and direction. You select one here, one point here, the other point somewhere here, and try to fix. You can't fix. Can you see? If I fixed it like this, this is going to be, this going to here, it is going to go out the existing center line. But what about this radius? You can select it and put li enter list. Here radius is 74. So what is our minimum one? It's 95, right? So here you have to take a decision whether you are going to have, whether you are going to improve this or not. So that depends upon your decision and the financial capability of your institution. Whether we are going to go for such a improvement or not, that you have to decide. Otherwise, you will have to go for a lesser design speed here and change. Now, just think that we are going to go for this what you call 50 kmph speed. So we'll have to take plotting curve and select entity to attach to. I selected, and then I'll go for the minimum one because that is what it seems. Okay, if it is not like that, then you can of course go for some higher radius. So we'll go for 95 and check less than 9. Yeah, so this is what I am coming. Look what happens there. Even 95. No, you can't. So you will maybe the one is 75, so maybe you will be forced to go for 75. 75. If I put it like this, just think, if I put it like this, now you can see 75 is okay, but I am narrowing the curve. Can you see? If I go to this side only, I am improving the curve. Here I am narrowing. Okay, so one tactic that you can do is you can select this, alignment, sorry, not that one, here, this one, sub entity editor, and then you can pick this sub entity and it shows your parameter. So you can increase the radius. I'll go for 80 here, or maybe 85. 85 is too much, so I'll go for 80. Still this is bit narrowing. So what about 82? 82 will be okay, but the problem is usually we usually don't go for this kind of odd numbers. It's better if we can go for 80 or 85, right? But if you can't change, if you can't help, then of course you can't do anything. Now I can't teach you, anything about how to design. That you have to decide yourself. Now maybe, right? Now maybe this is not going to work. We don't know, right? That depends on you have to go to the field and check. Now before proceeding, I'll ask you a question. Now usually I don't know, you don't answer, so I'll answer it myself. But my question is, why did we create the surface here? Now, do you know anything about whether it is a precipice or a mountain or whatever? No, you don't know. So one thing you can do is you can draw a line. You can draw a line perpendicular to, near perpendicular, need not to be exact, perpendicular to the center line, and then you can draw a profile and check what is the cross section here. You select this, right click, pick profile, and here change that into 1000 press OK and paste it here. This is your road cross section there. Can you see? This should be the road. Now RHS side there is some rise, and LHS side No, it's not a precipice or anything. Okay, so you need not worry. Okay, so you can go anywhere you want, this side or this side. But you just think in a mountainous road where there is a mountain one side and the precipice the other side. So you will have to decide where to which side you are going. Is it to the precipice side or to the mountain side? Okay, that is why we want that surface before deciding horizontal alignment. Okay, so now I am not very comfortable with this curve. You know why? Because here it is being bit improved. So I don't know whether this is possible. So what is the here radius is 82. So I'll go for something like 85. Oh, what about 80? 80, the problem is I will have to, maybe I'll have to come this way, right? Then it seems okay. So maybe instead of two compound curves, you will have to go for three compound curves. I don't know. We'll see what is happening, right? So now what is this one? This is 80. After that, I'll try some little bit higher curve, say 100 or something. Now just check how you are going to design a compound curve, right? Again, I'm taking floating curve, right? Select entity to attach to. Now select from this side, right? Don't go and select from this side. Then what happens is here end of selected entity already has an attachment because it takes like this. So you have to come here and select. Specify radius. So I'll go for say some 150, lesser than 180. Then it asks is curve compound or reverse to curve before. Before curve. It should be compound, right? Why? The same direction. So I'll select compound. What is this red color one? That means you can't place it there because now there's no such solution. Okay, so you can't place like this. So my assumption is wrong. You can't go for 150. If I'm going to go for 150, I'll have to go like this. Escape. So maybe I'll try say 100. 100. This is an 180 compound. Even 100 is not going to work. So what are we supposed to do? Or maybe this may be a lesser curve. We don't know. We'll check. So our minimum one is 55. Remember? Okay. So we'll go for some 60 curve. Lesser than 80 compound. 60 is okay. Can you see? So my earlier assumption was wrong, right? So it is a compound curve. This one is 80 and this one is 60. And now it perfectly, oh, you can't say perfectly, but almost it matches with the existing topography. Then there is a easy one, right? What is this? A line. So we'll go have a line, floating line. You select this one, specify endpoint. There also this is going towards LHS, right? So these things, of course, you have to go to the site and check whether it is possible. Now there is a compound curve. Can you see? No, reverse curve. So we'll check how we are going to do that. Plotting curve from entity radius 2 point. You select this one. So maybe it is say 150. I don't know. We'll see. Lesser than 180, 150. I'll place it here and check. It is 150. Now you can see you are narrowing the curve. Here you are narrowing the curve. So you can improve the curve radius here. Say 200. Yeah, 200 seems okay, but you will have to take this here, right? Then there is another curve. It's compound, right? We'll try 200 again. Select entity to attach to. Then we'll select this one. Specify radius. I'll again go for 200, lesser than 180. Now here this is reverse. Okay, there is another curve. So that means it's again reverse, the other side. Again we'll take 200. Radius, yeah, 200, lesser than 180, it is reverse. Seems it works. Okay, now time to time, save the drawing, right? Because the civil 3D is having a very good history of crashing. If it crashes, everything is gone. Now there is a line, floating line. So I'll place it here, enter, and there is another curve. How much do you think? 200? We'll see. 200, less than 180. It is greater than 200. So you can improve it. How much would it be? 300? No. Then we'll go for 250. 250 is okay. Right? Then we have another curve. You have to assume. We'll say 200 reverse. Now you can see that curve should be narrower, right? So we'll go for say 150. No. 180. 180 is perfect, right? And then there is a small straight plotting line, right? Then of course in such locations, of course you can take a decision whether you are following this one or whether you go for some change, because this is it seems like an unnecessary reverse curve. So, but you have to check here, there are some buildings, I don't know, Sanduni Fashion, Bearland, Sub Post Office, no. So you can't go for such a development. Maybe you will have to follow the existing one. But just in that this whole thing is Bearland or a paddy field or something, then of course you can have some development. Maybe we'll have to follow the existing one. So we'll go for say 200, less than 180 here, and then again there is another curve. So maybe again 200, then 180 reverse. So again there is a curve. Maybe it is say 100. I don't know. Reverse. 100 seems okay. But I am not very comfortable about this curve. It's a small curve. Other thing is 980, 1020, only 40-meter curve. So what if we delete it? Instead of having a curve like this, What if we get it like floating line and then try to straighten it like this? So you can always have, so what is your cross section? 3.5, 1.5, that is 5, and then 2, 7, and if there is a drain also, it should be zero point 0.6. So you can put offset like 7.6 and check what will happen. So it's like, it's going up to the edge of this building. So maybe you can do something like, instead of going there, there's one thing you can do. You just draw a line here. Now these are the actual practices we do, right? Okay. Now this is maximum you can go up to here, right? Just think that is the maximum you can go. This line. Beyond that you can't go. So you get something like say 8 meters to the other side. Now this is the line that you have to follow, right? So what you can do is, your alignment is like this. You can go here and then you can have, a line like this, right? Will it work? We'll see. Now I am going this way, and now I'll go for 7.6. Now it seems okay. What about here? But they are going to be acquired. What if we are going to follow the existing set line? 7.6. These six you have to take decisions, right? That cannot be offsets because it's a polyline. Anyway, you can. What is this one? You can have to get my dimension toolbar was not there. That is why I put it here. So just check. No, we'll draw a line. Now this is the maximum place that you get towards their side, right? That's the maximum place that you get towards their side. Now gets 7.6. What happens? Now still their buildings are going to be acquired. Can you understand what I did? Now if I followed the existing center line, this is the maximum point. The existing center line go towards their side. Now if I offset it to 7.6, still I'm going to acquire this land. So I can go this way also. At least I have saved this path. Otherwise what happens? You are acquiring from this side and other side also. These things that you have to check at the side. And maybe, I don't know, this is only my assumption, right? But maybe you will have to go to the site and see. Sometimes these are some old buildings that nobody lives there, and here people are living. Then of course you will have to take this alignment towards the LHS. So these are the decisions that you have to take in the field, because you are following engineering, right? So it is not kind of an office exercise. So here we'll go for say 150, no, 100, right? And then you have plotting line like this, right? So we have come up to 1 kilometer. So I think that's enough. So you can practice with that. Save the drawing. And what about having a small break? About 10 minutes like? Okay. Right. So yeah, so we were here. Now this is our alignment. Now we are going to create our profile, right? So it's like a crash course. Quickly we finish align, create the surface, and then we create the alignment, and then we are going to go to the profile. Now before that, of course, if you want, you can create your other alignments as well. So what are these? Now this is how you do that, right? So you have to have your lane edge, that is 3.5. So you can offset your alignment by 3.5. Here it's 3.5, the other side 3.5. So you can make them alignment also. It's not a big thing. You can quickly do that like this. Alignments, create alignment from polyline. Earlier we selected create alignment by layout, right? Now we select create alignment from polyline. So they say select the first line, the polyline. So we select here and I press enter. Press the enter to accept alignment direction. Now the direction in the sense maybe you see here. Can you see? This is the direction, right? Otherwise you can reverse. Now this is okay. Why? I selected it from the beginning, right? So I press enter. Now I have to give a name. Usually I give DLHS, that is design lane LHS. The type should be offset and site is I design. Alignment style is this one and label style is UM. So you have to remove these things, add curves and keep erase existing entities, because then what happens is this line is erased and only the alignment is there. Okay, so press OK. So now you can see, I forgot one thing. What is that? Here there is another label set came, but you can remove that. You can go to edit alignment labels. Here you can import label set, no labels. So the labels are gone. Now don't worry, you will understand it when I do the second one, right? This one, right? Alignments, create alignment from polyline. Here I select this, press enter. Then it asks whether I have to reverse it. No, because I selected it from the beginning. Press enter, give the name DRHS, that is design lane RHS. Type is offset, site is site design. Alignment style, you remember that we changed it, the name changed, otherwise it was EON, right? Then the alignment label set, of course you have to put no labels. That is why I forgot, that is where I forgot, right? So you remove add curves but keep erase existing entities, because if you give some label set, it gives the label set. Don't give the labels, because the label set we only want for center line, not for the tie, so not the tie lane is okay. So we'll press OK. Now you can see another alignment is created, right? And then we'll go to what? We'll go to hard shoulder, that is 1.5 offset. Object 1.5 offset. This side and this side. Okay. So I can make them also alignments. Alignments, create alignment from polyline. Select this one, enter. No, I don't want to reverse, enter. You give the name like H hard shoulder, LHS. Type is offset, site is site design, alignment style is this, but don't give alignment label set. So no labels is okay. Uncheck add curves between tangents. So erase existing entry should be there. Press OK. Right. Then we'll go to this one. Okay. Alignments, create alignment from polyline and select this one, press enter. So this one H RHS, type is offset, site is site design, no label, same thing, right? Uncheck add curves between tangents, but check the erase existing. What I mean by check is ticking this, right? Press OK. Right. Then the soft shoulder, that is 2 meters away from this offset there. 2 meters, 2 meters, right? Then alignments, create alignment from polyline. You select this one, press enter. No, I don't want to change the direction. Press again enter, and then give S soft shoulder, right? Soft shoulder RHS. This is not necessary for our design, right? I mean, in the sense for the profile or cross section, but the line should be there. Okay, type is offset, site is site design, alignment style okay, no labels, label set is no labels, uncheck add curves between tangents and press OK. And again you go to alignments, create alignment from polyline, select this line, press enter, and this one S RHS. Type is offset, site is site design, alignment style is this one, same, alignment label set no labels, uncheck these add curves between tangents and check this erase existing entities and then press OK. Now OK, right? Now all the other alignments are created. Save the drawing. And now if you want to have labels, now if you want to have labels, that means the curve radius and things, of course you can put them here using Civil 3D. How? You can go to alignments, uh, add tables and renumber tags. This is in the book, right? Okay, this is in the book, renumber tags. So you press S to give settings, line starting number, you can change, everything should be 1, right? Then only it starts from 1. Press apply and press OK, and then you go to alignments, add alignment labels and multiple segments, and then select your center line alignment. Now you can see here, this is L1, length is given, this is C1, radius is given, radius of the curve is given, and the length is also given, right? Here C2, curve 2, radius is given, length is given. C3, radius is given, length is given, right? Now I'm going to save this, right? Now maybe you are a bit worried now, he did it in a rush, so how can we understand it? No, these are nothing. Okay, what we really do is we take the offsets and then make them alignments. That is for our future designs, in the sense for the profile and the cross section, that's all, right? So because I'm going to upload this video also, and also I have given you the book, so you can refer them for your practice, right? So we'll save this as, now this is finished, we'll save this as profile. Save as, you give the name as profile. Okay, save. Now here the name change to profile. If I put it like this, so maybe it will come like this. Okay, so don't worry, you go back to this one, or else you go to model. So I'm going to create the profile. So how I'm going to create the profile is profiles, create profile from surface, profiles, create profile from surface. Here there are all alignments. There is one problem. What is that? Here, what is name? SRH, that's wrong, right? It should be SLHS. And then here, alignment properties, it should be SRHS, not 1. Right. Now we'll go to say profiles. Create profile from surface. Here DCL, these all the alignments are there. We are going to create the surface for our design center line. So that is DCL, right? And now this is the EG, select surface. EG means the surface that we created. You are going to add it into the profile set. Add. And then you go to draw in profile view. So they ask you to give a profile view name. So you can say EG profile. Profile view style is 1000 Next. Then station range you don't want to change. If you want, just think that you are having say something like 30-meter road, sorry, 30-kilometer road. Then of course you can't create everything in one file. So you can change it using user specified range. Here, since it's just 1 kilometer, no harm. Okay. Then profile view height, they have suggested a height. If you want, you can change it by giving user specified. Then you go to next. Profile display options, we are not going to change anything. Data bands, we are going to have our customized one, 1000 Here we are not going to change anything, later we will change. Okay. Here, can you say station? FRL means finished road level, EGL means existing ground level, VGO means vertical geometry, HGO means horizontal align, horizontal geometry, and SC means super elevation. Okay, but we are not going to change anything. Now this is as it is we are getting. Later we are going to change them, right? So we go to next, profile hatch options. Uh, no, you don't want to change anything. Later we'll change if necessary. Create profile view. So they say select profile view origin. You give a convenient place. Put it something like this. Now this is your existing profile. Can you see this is your existing profile? The road as it is existing. Now uh, what we are going to do is we are going to design the existing profile. Before that, of course, you have to read your vertical alignment notes. Okay, so I have given you as a presentation, or else I have a note with me here. I'll show you. The minimum one that we have to give is, we have to ensure that stopping side distance is, you have to ensure that stopping side distance is, can you see this? I think, right? So you have to make sure that stopping side distance is ensured here. So if it is 50, you have to give for this is for a crest curve, right? Minimum k value should be 9.8. Okay, and if it is a sag curve, 12, k value should be 12. So remember 9.8 should be selected, not in the selected, you mean minimum k value of 9.8 should be there for a crest curve, and for all your sag curves it should be 12 k value. So what will be the curve length? That you have to refer the table. Okay, somewhere it was there. Now 50, so that means the curve radius, sorry, not the curve radius, curve length of vertical curve should be 50, right? So please keep that in mind when you are going to design it, right? Right. Now I am going to design the vertical line. Before that, you can see the levels are given in 20-meter interval. Now can you see finished road level is now only you can see your application. Right. Now here this is the existing profile. I am going to design the finished profile. Now you can see, if you see the finished road level and existing ground level, both are same. Why? Because we haven't designed a finished road level yet. And vertical geometry is a mess. Why? Because it is the existing one that we are having, and super elevation is not given. So we'll have to do all these things. So we'll do that, right? So if you want, you can have this into 10-meter intervals. How? You can select this profile view and then go to profile, edit profile view style, and here you can see major tick details is 20, so you can make it to 10. So you should be under this horizontal axis tab, right? Press apply, press OK. Now in 10-meter intervals you are getting this, right? Now let's start designing the vertical geometry. Now before that, you have to keep in mind three parameters. What are they? For a crest curve, the k value should be 9.8 minimum. For a sag curve, the k value should be 12 minimum, and the length of the vertical curve should be 50 meters. With that, we'll try to design. Now in designing, what we do is, first we'll try to match our design profile as much as possible to the existing profile. After that, we have our payment design. We'll have to assume, because it's not given, if it's a real project is given. Now we'll say it is a bearing cost, please note down. Bearing cost 40 millimeter, and binder cost 60 millimeter, and ABC 150. So everything comes to 250. So we'll uh, go into that pavement design. Okay. If it is a real project, of course, the pavement design should be available with you by now, right? So we'll go to design profiles, create profile. Earlier we selected create profile from surface. Now we are going to select create profile by layout. Now it says select profile view to create profile. I'll select this one, and you have to give name. I'll name it as FG profile. Better FR. Why? Finish road. Okay. FR profile. And profile style, you have our uh, our customized label set, label and profile style. Profile label set also you have this customized one. Now press OK. And now first thing is, we are going to have VIPs, that is vertical intersection points, or we call it PVIs, that is points of vertical intersections. Anyway, whatever the way you can have. So I'm going to draw tangents. So the first thing, I'll start from the existing one, right? Now if it is 50 meter, definitely you have to have at least here, right, 25. Otherwise you can't have another curve, understand? So it should be like this. So you have to follow it as much as possible to the existing one. Now don't worry, you can later change, right? You can later change these points. So we can go this way, right? Now just you can go on drawing like this, later you can change, right? Now once you press enter or escape, you get here IP station is coming, IP elevation is coming. These are IPs, that is intersection points, right? Then we'll try to insert the curves. Before that, there's another thing that you have to check. What is that? The gradient. Gradient should be, it should be greater than zero point 0.3, right? Now we'll see here 0.16. You can't have that. So you have to make it to zero point 0.3 minimum. Here 0 0.1. You can't allow. Why? Drainage problem, right? Zero point 0.3, right? Not 3%. Please, now here it's almost flat. You can't. Okay, so you will have to change these things. Now we'll start from this, from the beginning, right? Now you can't have your design profile like this. Why? You can't cut the surface, right? So you have to think all these things before you start design. So using this move PVI tool bit, you can move them like this, can you see? Better you have offset switch off, and you have to have say minimum 25. So maybe it's like this, we'll see, right? So one thing you can do is you can take this into, now just like the alignment, you can take into say 25, right? 25. Now check, this gradient is okay, this gradient is okay, here is 25. Now we don't put into some odd values, like, because these are good practices, right? And if it is 25, can you have somewhere here 60? No. What is the minimum value you can have? 75. Why? If it is 25, half half of this curve comes here, that because our curve length is 50, half of it is 25, so 25 25 it is 50. And if we are going to have another curve, because if it has an intersection, so VIP PVI, you have to have another curve, so there comes another 25 there. So it is 25, half the curve 25, that is 50, and half the curve 25, 75. So you cannot have 60 here. So we'll remove that and press enter, right? So your minimum one should be 75. So maybe we'll have to change these things. We'll see. And you can enter PVI like this. Say I'll enter somewhere here 75 like this. We'll see, right? Then we'll have a curve here. More free vertical curves, free vertical parabola PVI base. That is what we are using. Okay. More free vertical curves, free vertical parabola, PVI based, right? Pick point near PVI your curve to add curve. I'll select here and I'll give the curve length 50. This is how it's coming, right? Then this one automatically comes. IP station, IP elevation, begin vertical curve station. This one, begin vertical curve elevation, end vertical curve station, that is 50, and end vertical curve elevation. So you can change them. Whatever you want, you can change them later. Okay. So here we'll try to have this as 75. Okay. And if it is 75, you can go up to, you have to go up to 125. Yeah, 125. So maybe you will have to change that into 125. Okay. So we'll have another curve here 50. Later you will have to check the k values, right? If it is 125, you have to go up to 175 minimum. 175. And maybe you will have to drag this down like this. And again you will have to change this into 175 because once you drag it changes. Okay, so we'll try to have a curve here. 50, it seems okay. And if it is 125, you can have only 225. Okay, so you can't have an IP here. So we'll remove this IP also, and we'll try to have one at 225. Oh, what happened? Right. So we'll have 50 here, and then if it is 225, the next one, you have to have 225 properly. Then your one should be, next one should be 275. So it should be 275, right? And then let's have a, now I am checking these things, 0.56, 2.62, okay, 50, and then you can't have this one, zero gradient. Okay, so what you can have is, there should be another 50, right? 275, that is 325. That is the minimum place, but we don't want to go for the minimum one. Say we'll go for like this. So you have to make sure this is minus 3, right? Minus 0.3, minus 0.3. So that is the maximum you can go. So we'll have a curve here, 50, and after that you see it is 340. So the minimum one you can have is 390, but that's the minimum one, right? But you can match this with the existing ground like this. So before that we'll connect this to 340. Once you correct it to 340, you have to change it from here. Grade out is minus 0.3, minimum one, right? Then we'll take this into 405, right? Then we'll have 50 curve here, but you see it is not matching, so you can take it upward. Okay, so that means maybe you can increase the curve length, maybe 70 or maybe 80. 8 is perfect, it seems. So we are getting only 25 here. This will work, we'll see. Here we'll change that into 490, and here we'll have 50. Okay, now don't think that it is only curve and curve. This is just like roller coaster. If you are going to have curves and curves, so maybe you can have straights also. We'll see depending on, yeah, here okay, 0.86, 1.19, so we can have here 50, okay, or maybe 60. You see, 60 or 70. Now it seems okay, right? And then here you can't have this one. Can you see? It is 0.16, 0.06. So we'll remove it, and we'll try to have an IP point here. No, you will have to make it minimum zero point 0.3. Okay, now it is 620. It should be minimum zero point 0.3, right? So let's have 50 curve here. It's not going to work. Why? It should be 550 44. Oh no, here it has to come here 550. 550, right? Gradients are okay, so we'll make this into 50, and this one we'll try. What about going this way? If I go this way, the cut is going to be high. If I go this way, cut is going to be lessen, but I can come only up to here. Why? Otherwise I can't have a curve. So we'll try. So I'll go to here 610, and maybe I'll make this into minus 3, minus zero point 0.3. Now it seems okay, and here you can have 70-meter curve. 70. So that is all you can go, right? So that means yeah, so there is a cutting. Since there is ABC, of course we can manage, but we'll try later. We can try to change. So here, to match with this existing ground level, you can come with like this. Here, can you see? Oh, you can't go this way. You have to match with the existing one. Now check. The 76 is okay. So you can have here 755. Oh. Then this should be, oh, better. I think we can go to 750. Okay, 750. Later we can change, right? 50, and here let's go for 800. Oh, sorry, 800. And then again we can go for another 50. Here we have to go at least yeah, at least 25 meters. That is 850. And then you can go for 50 here, right? So you can remove that IP and check what's happening, and maybe you can take it here. So that is 1010. Okay, 1010. So you can have 50 here, and here, so you can make it 2090, and you can give 50 here, and finally say you can change this somewhere like here or here. No, this way, this way. 100, 1150, and you can give 50 here, or you can make it bigger, 60, maybe 70 will be ideal. We'll see. 70, yeah. So that is our vertical profile, but of course you will have to correct them. How you are going to correct? Now you see here, you can uh, lower this IP. How? Select this, say it is 311, sorry, 38.11. So maybe you can go for 37.950. Still you can reduce it or lower it, 37.9. Still some more, but in such cases you will have to check the gradient. Now you have to change this label set to reflect your changes. How? You select this one, you go to profile view properties, and here you know FRL, that is finish road level. Here you have to give the profile 1 as FR profile, profile 2 as FR profile. Okay, and then you have EGL, that is the same thing, right? That is the EG surface. And VGO, vertical geometry, that is FR profile. Others you can't change, right? So you press apply and press OK. Now you can see here, now this is a crest curve, vertical curve length is 50, K is 20. What about the gradient? Unfortunately it is 0, so you can't make that change. So you can check here, see, uh, no, what has happened is here, because there's no gradient like that, but of course you have to check like that, right? Grade in is 1.35, grade out is 1.2, that's okay. K is okay. Now this is perfectly okay. This sag curve, K is 33, our minimum is 12, okay. Crest curve, vertical curve, vertical curve length, of course we are giving, therefore we don't have to worry about it, but you have to worry is K, right? So this is a crest, so the K should be 9.8, that's okay. Sag more than 12, okay. Crest 16, more than 9.8, okay. Sag 22, more than 12, okay. Sag, okay. Crest, okay. Sag, okay. Just check wherever if you are having more than the lesser than the required values. No, right? So then you have to match this much as possible to match with the existing profile, but it is not always possible, please understand. If you can do that, then of course you don't have to do any design, because the road is okay, perfectly okay. Road is not that way, that is why you are going to have feelings like this to match it into the 50 kmph design speed. Finally, what you are supposed to do is you can raise this in according to your pavement design. You know it is 40 millimeter the wearing course, 60 millimeter binder course, and 150 millimeter ABC. So that is altogether it comes to like 250, right? Did I sum them up correctly? Yeah, 250, right? So using this one, trace lower PVIs, elevation range, PVI range, all. So elevation range is 0.25. All. You press OK. Now can you see everything is traced at once? But you have to do one thing. What is that? Now can you, because this is where your project starts. Now, can you have a step like this? No, you have to take it into the existing one. It's like this. You know our existing level is 37.5112, 37.512. So you bring it back. It should be 0, right? 0. It's not showing some error. And then H, it should be 50.523, 50.523, 50.523. So you are merging it with the existing rod. Okay, right. Then our vertical profile is designed. Please understand this is a kind of a basic introduction. Okay. Of course, there are a lot we have to do. We have to consider about something called recambering. So what is this recambering? You know, when we are going to design a new road, sometimes the existing the design center line need not necessarily be on the top of the existing center line. So once you change the center line, what happens is the camber. What do you mean by camber? You know, the road is cambered towards the center line. So from the center line, one side minus 2.5, other side minus 2.5. So that has to be changed once you change the design center line. So that should be corrected. Now these are some advanced things. Of course, we don't have time to cover all these things, but remember it is there in my book. So you can read them and try it yourself. There is a description also what is recambering and what we are going to do there. Right. Then the next thing is to insert superelevation. Right. Superelevation. Now I am not going to calculate any superelevation. Last day I taught you how to calculate superelevation development length. Since we don't have time, I am not going to do that. Instead, I'll suggest that our superelevation development length is 36 meters. Okay, that is a normal thing that we get for our normal roads. If it is 36 meters, then one third of it comes to comes inside the curve and two third goes outside the curve, right? So for that we have to enter the super elevation manually, right? Otherwise we can use our that super 1000 excel sheet also, right? But anyway, well, let's check whether I'm having that one, then I can show how we can do. But of course you should know how to manually enter. We'll see whether I'm having. No, we'll go for the manual one because otherwise you cannot study, isn't it? So come to this general tool space, and in the prospector you know alignments, sorry, sides, under that side design, alignments, center line alignment, then there is DCL. So I am going to insert super elevation there, right? So you go to right click and go to edit super elevation. So never go for this calculate super elevation now, because the calculate super elevation option does not give our Sri Lankan standards. Okay, so you have to go to the open super elevation curve manager, right? And then you go to this tabular editor, right? So in the first curve, curve 1, you can right click and add station. You have to give your starting station. So it is 0. Right, so if you expand this you will see transition in region, there's a manual station. You can right click and give assign critical station. You can give whatever you want because that is no influence to the super elevation, that is just the starting point. So we'll give begin normal crown and these four: left outside shoulder, left outside lane, left inside shoulder, and these four and these four, right? Right inside lane, right inside shoulder, and all these things should be minus 2.5. So you can just minus 2.5. If it is not coming like this, there is a bug. So you close it and again go to tabular editor and then try it, then it will work. Okay, so you can copy and paste it everywhere. You have to enter the same value 8 times. Is that all? No, 8 times. Right, now you can see normal crown and it's minus 2.5, and you have to give the n1 also. N1 always try, don't give this the last digit, you go for this second digit. Okay, so tabular editor, this is the last curve, add station 1186.91. Here transaction out region manual station, you change this to assign critical station n normal crown, and here also you have to have the same. It's not working, then again you will have to close it and go to tabular editor, and then you can paste it. This is some tiresome work, that is why we have developed some macro enabled Excel sheet. Okay, but if I give you now, what happens is you will not understand how to do it manually. Okay, so I will show you how to enter super elevation for one curve, because we don't have time, right? For this curve, it is 55. Now you know, if it is 55, so what will be our radius, the super elevation? It should be 4, right? If I remember correct, it should be 4. Yeah, it's 4. So I'm not going to enter super elevation there, because then we'll see. Yeah, I'll enter super elevation to this curve. No, or else we'll go for the first one, but it should be 4%, right? That's the thing. So we'll have to calculate the superelevation development length, but I'll take it as 36, right? So we'll try. DCL edit superelevation for the first curve. W editor, this is the first curve, right? Add station. So I have to check. Now you know it is 59, right? 50, because we take the, we approximately take it, I mean we round off 59, right? So you have to take, you know, if it is 36, 24 out, 12 inside. 59 minus 24, how much? 59 minus 24, that is 35, right? So we'll go for 35. Here manual station, that is n normal crown, because normal crown is going to end there, right? So it has automatically come. Why? Because this side minus 2.5, this side minus 2.5, that is okay, right? So that is normal crown. And you know, if it is 35, then we have to go for 36. Why? Up to here 24, up there 12, then it should be 36. So 71 is the normal crown. 71, begin the full super elevation. Okay, It is 71. 71 is the begin full super. So now it is okay. But just think, begin full super elevation. Fs means full super elevation, right? L is minus 2.5, R is minus 2.5. That's wrong. So here you can see it rotates this way. So LHS side should be high. So L should be 4. Understood? L should be 4. So L should be 4. Only L, right? L should be 4. And R should be minus 4. Understood? R should be minus 4. Why? That's the super elevation. Right? But there's a problem. We don't draw super elevation like this. Okay. So you have to come now. One thing we can do is, up to now I am doing a trick, right? Now this is 2.5 line, right? This is 2.5 line. And this is the center line. I am just drawing AutoCAD lines, right? Now you check what is the difference in between. How much? For no, it doesn't come perfectly. 4.2344. So we'll offset this 4.2334. Otherwise you have to calculate, right? Delete, and I'll draw this line also, and I'll extend this one here. Add now the thing is, at this point, only you will have to turn this super elevation down. So you should find what is this point. It's easy. How much? First check whether, what about this scale? Check this one, 35, 71. So it should be 35. That's okay, no? Fairly okay. So then here, from here to here, how much? 7.78, say 8. So that means your reverse crown is 8 meter away from this 71. So 71 minus 8, 63. So we'll go for 63. Otherwise you have to calculate. I'm just doing a tactic, right? 63. So that is reverse crown. So here LHS, since we are traveling, we are revolving into RHS side, LHS should be raised. So it should be plus 2.5. And right side it should be minus 2.5. Now can you see? It came perfectly. Of course, please understand, I just played a tactic. Okay, you can't calculate it like that. But the thing is, the theory is because up to 2.5, this has to come like this. Then only it is turning. Okay, that's the theory. So what I did was, looking at the diagram, I did it. Otherwise, you have to calculate what is this point using the equations. But anyway, the same thing happening. Here, we'll save this one, right? And then, now, if anybody didn't understand, please check what I am doing to the other side of the curve. Same thing I am doing, right? How? Now, our end of the curve is 135. So what is our superelevation development length? It is 36. Okay, I assume that, right? Then 12 should be inside the curve. So 135 minus 12, it is 123. So you have to finish your superelevation in 123. So we'll go to edit superelevation. That's the first curve we are still handling, right? First curve, add station, that is 123. 123. 123, that critical station is n full super elevation, right? So usually I check it and come back, otherwise I can't enter anything. So this is the begin full super, the same thing has to come there for, and right side should be minus 4, like the earlier one, minus 4, minus, sorry, minus 4, minus 4, and minus 4, right? So it is 123, then I have to take 36. How much? 159. So the same one, same curve, at station, that is 159. Okay, manual station. So that is begin normal crown. Why? The normal crown is going to start again. If it is normal crown, it should be minus 2.5. Right? Now this is okay, but the problem is, again you have to give the reverse count. Now you know it should be, how much is it? 63, 71 means 8 meters. So same thing comes here. 123 plus 8, that is 131. So we can give 131. 131 reverse crown. Sorry. So reverse crown is here. It should be plus. Understand why? It's 4. Then it should be plus 2.5. So I can copy it. Minus 2.5, minus 2, sorry, plus 2.5, and then minus 2.5, right? Then I can copy them. right? Now it is perfectly done. Super elevation is perfectly done. Of course, if you really do it, you will have to calculate this the super elevation development length at the first, and then this is end of the normal crown. This is the full super elevation beginning. Begin full super. We call it in civil 3D jargons, and this is the reverse crown where that the lower side super elevation is going to turn, and here this is the end of the full super elevation, and this is the beginning of normal crown, right? And here again where the lower side super elevation reaches minus 2.5, because you don't draw it like this, understand, right? Because up to 2 minus 2.5 it goes like this, then only it turns. That is the convention, right? Okay, so that's the end of the super elevation. So you have to insert super elevation everywhere like this for all the curves, understand? You have to calculate, and so that is the hardest part of civil 3D, so not civil 3D, highway design. Okay, you have to have super elevation. That is why we have developed an Excel sheet for that. Anyway, we don't have time to discuss that, because I want to cover something about the cross section. Okay, so we'll go to that. Drink some water. Because it's going to be hard, but anyway, we'll cover. We have almost 1 hour. We'll cover that, right? So save this as first save it itself. Okay, after that save it as file, save as we'll put cs cross section. Okay, and to do that we want to have two another alignments. What are they? One is existing tie edge, other one is existing tie edge LHS, other one is existing tie edge RHS. So we'll make them also alignments, create alignment polyline, same thing, right? You select this one, it's not going to be selected. The thing is, if they are not going to be selected, you can select them, right click, and then you can go to isolate selected objects, that will be selected, so you can explode and then make them polylines. Okay, the thing is it is not properly made into polyline, so you can explode, type explode, select them, press enter. Now you can see they are exploded, so you can bring them into the zero plane by giving the command flatten, 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 select them and press enter. Remove hidden lines, no, enter, right? Then you can make them polylines by this equation. Please note down if you don't know. Maybe you know because AutoCAD stuff. PE, polyline edit. Select polyline no multiple. Press M. Select objects. You select everything. Convert lines, arcs and splines to polylines. Yes or no? Yes is selected. Yes. And then use enter an option J. You double enter it. No, then enter. First is 0, you enter. Now you can see they are being polylines. Press again enter and then press escape. Now they are two polylines. If you are not very comfortable with these two line types, you can just match them. MA enter, MA enter. Select the source, select the what you call the destination, right? So you can come back by isolate objects, end object isolation, right? Then you can make them alignments, create alignment from polyline. You select this one, press enter. No, I don't want to reverse. You give it as ELHS, type is offset, site is site design, alignment style is okay, no labels, add curves, remove, erase existing entities, also remove. Why? Because the existing alignment should be there as it is. Okay, now you can see the line is also there and the alignment is also there. So you have to make the RHS, tied RHS also into an alignment. Create alignment from polyline. No, I don't want to reverse. Give the name ERHS and offset. Site is side design. No, remove add curves between tangents. Remove erase existing entities also. Now it's there. Right. Now, how we are going to create cross sections? We have to have something called an assembly. Okay, we have to have something called an assembly. So that is very easy. How you do is corridors create assembly. Corridors create assembly. So we name it as a CSS. Assembly type is undivided crown row. Why? Because it is undivided. There is no center median, right? Assembly style is assembly. Code set style is finish. That is the one that we have customly made. So press OK and it says specify assembly baseline location. We give a location somewhere here, and you better draw a circle around it, otherwise because it's very small you can't see, right? Then we have to model. Now what we are trying to do is we are trying to model our road. Now in our road you can see here there is an existing road, right? After that there is the widening section. Can you see here this purple color line are existing road, then the widening section, after that hard shoulder, after that soft shoulder. So that is after that, after soft shoulder, so it is cutting or filling. That is what we are going to model, right? So first we will model the existing road. For that you go to general, tool palettes window, and there is a tab called rehab. You have to take overlay mill and level 2. Now, if you don't understand, I know because I am rushing because due to the time constraint. If you don't understand, don't worry. Just see how I am doing. Later, I will upload this video to internet. You can check. Also, you can refer the book, and then you have to practice yourself because you know this is a software, right? Since it's a software, you have to practice it. Otherwise, just by looking at the screen, you can't understand anything. Only thing is you just get an idea what I am doing, listening to me, right? Okay, so we are trying to model the existing road. So I'll get overlay mill and level 2, and I'll now it says point within assembly. Okay, so this assembly, escape, then you select this one, select your sub assembly, right click, sub assembly properties, you go and change the parameters. Now look at these parameters. Crown point offset. If because that what they are asking is if your crown point need to be changed. No, 0. Left sample point offset. What they are asking is the your lane width LHS, that is minus 3.5. Right sample point offset, that is plus 3.5 because the lane edge. Left trim means what is the existing tire? We don't know. We give a rough value minus 2.5 and right trim point plus 2.5. Then left overlay slope options we give outside lane superelevation. Default left overlay. That means if there is no superelevation given, it should be minus 2.5. Right overlay slope, that is outside lane superelevation. And if there is no superelevation, we give minus 2.5. Don't give any tolerance for the slope, 0. Use profile, you have to set it as use profile. Minimum clearance, that is the ABC, 150. Overlay depth, that is 100. When you press apply and press OK, Now this is your your existing road is formed. Now this is up to 2.5, this is up to minus 2.5, and you have to have another 1 meter for your new road. For that you have to have lanes, and you go to lane outside super multi-layer, and you have to attach it here, right? And you have to change the parameter. Select this one, go to sub-assembly properties, give the name lane outside super multi-layer R. Why it is RHSI. Then go to parameters. Side is right. Insertion point is edge of travel way. Crown point on inside no. Width is 1 meter. Default slope is minus 2.5. Super elevation slope is right outside lane. Lane slope direction is away from crown, that is okay. Pave 1 depth. How much is your width? The depth. That what they are asking is the wearing cost. 40 millimeters, right? Pave 2 depth, that's binder cost. Is there any pave 3 depth, that is the regular cost, anything? No. Base 1 depth, that is 150. Others we don't have. But since this is the widening section, maybe we'll have to have some sub base. There should be soil because there's no road here now for the time being. So we'll go for say 300 millimeters, 1 foot, 1 foot soil, right? Then you can mirror this here. Now please understand, when you mirror, you select it and go to mirror within assembly, but you don't select. Now usually we mirror from the center line, but here you have to select this point, right? And there you have to change the parameters. You go to select it, sub assembly properties, you change the name into L, right? And parameters, here only one thing you have to change, that is super elevations of left outside lane. That's all you have to change. Press apply, press OK. Now you have to design the what you call uh, hard shoulder and soft shoulder. For that you go to shoulders, here shoulder vertical sub base. You select it and insert here, and then we'll change sub assembly properties. You go and name it as R. Parameters, paved width is how much? 1.5, right? Side is right, that's okay. Paved width means hard shoulder width. Use super elevation slope, you use right outside shoulder. Shoulder slope direction is away from crown. Default paved slope, remember paved slope, that is minus 2.5. Unpaved link treatment, you keep it as it is. Unpaved width is 2 meter, soft shoulder. Unpaved slope is usually in Sri Lanka it is 4%. Unpaved maximum breakover, you keep it as 8%. Okay, don't change. Then pave 1 depth, that is 0.40. Pave 2 depth, that is the bearing cost 0.60. Base depth, that is it is 150. Sub base depth is 300. So if you have any question, there is something called sub assembly help. Okay, you can go there and see, right? Autodesk. So how you are going to use them, right? Apply. Okay. Now you have to have cutting and filling. For this you have to have daylight. There's one thing called daylight. You have to you have to mirror it. Mirror, and you come here, and You have to right click subassembly properties. You name it as L and go to parameters. Only one thing you have to change. Use super elevation slope left outside shoulder. Okay. Apply and okay. And then you have to have daylight multi intercept, that is the cutting and filling. Okay. So here you have to change only two parameters. You don't want to name even the you don't want to change even the name. Parameter is, cut slope, that is 0.25 to 1, fill slope, that is 1.5 to 1. Okay, so if it is a cutting, it goes like this. If it is a filling, it goes like this. You mirror that also. Mirror. Okay, now this is your assembly, that is the modeling of your rod. So this section is the existing rod, this is the widening section, this is the shoulder, this is the cutting and filling. Now if you want to add drain, you can add, that is there in my book, right? So you can try it if you want. If you want to add a center median, that is also possible. Now we'll create something called a corridor. That means we try to run this along this center line and along this profile. Understand? That is how you have to have the cross sections. Okay, you run this one along this center line and along this profile. We'll try to do this using a corridor. Corridor, create corridor. So you have to give the name as, say, you can give a name CS. Baseline type is alignment and profile. Alignment is DCL. Profile is FR profile. EG profile means the existing one, right? So FR profile. Assembly is the CSS, that is the one that we created. Target surface is the existing ground that we created earlier in the morning, right? So here we have to do some changes in the frequencies. Everything should be 10. Curve increment, that is 10. Along spirals, we don't have spirals. They are asking whether I have to run this corridor in horizontal geometry points. That is why yes or no. But we have not taken levels in the horizontal geometry points. Therefore, there is no use. Superelevation critical points, we have not specifically taken levels there. So it's no. Along vertical curves, that is the interval that we have to run. At vertical geometry points or high or low points, we haven't taken levels specifically, so you give no. Offset targets also, we have not specifically taken levels because we have taken just levels in using the total station. So there's no point giving, right? Then you go to target, and here you have to set the target EG. Then these things you have to, because you have to get the practice, then only you can do the crown offset, that is a crown. So that is DCL. You press add here, press OK. Left sample. Left sample means, I told you sample means the design lane edge. So that is DLHS. You remember. And left trim. Trim is existing one. ELHS. Right sample. That is D. So that should be the lane edge DRHS. Right. Right trim. That is existing RHS. Right. So they ask what is the width target. Here they are asking the R1. See. So it should be design RHS, DRHS. Then they are asking with target design LHS. So it should be DLHS. Paved with, that is hard shoulder, HRHS. Paved with target. So that is they are asking LHLHS. Okay, then okay. Apply, rebuild the corridor. Now your corridor is being created. Can you see this is your corridor? That means we have run our assembly along the center line according to this profile. So that is what you call by corridor. Save the drawing. Now you have to create the corridor surface. That means you have run the corridor and you have to create the top surface of that corridor. That's very easy. You go to tool space and you go to corridors. Here this CS is there. You go to properties and you go to surfaces. You add here a corridor surface and you add here data. Okay, top. And press apply. Rebuild the corridor and OK. Now if you go to your surfaces, earlier there was only EG, now here is your finished ground surface according to the corridor. Okay, that's also added. Now we are trying to do the cross sections, right? Now we are trying to do the cross sections. For that we want to cut this corridor in 10-meter intervals. You can't cut it using a knife. We have to have a tool that is given by the Civil 3D software. So you can use sections, create sample lines and right click. Here alignment should be DCL. Press OK and you give the name. Usually we give the name SLG1 and sample line style sample line. Sample line label style is name and section. Here only here you have to change that into finish. Okay, then press OK and then go to by range of stations. Station range, whether it starts from the same one 0, yeah, if you want you can change them, right? If you want you can just put false and then change. If you put it true, it is the same thing. Snap to and left swept width means what is the width that you want the cross section. Usually we give 15 meters, right? Also 15 meters. And the sampling increments, that is where you have to cut it. Usually we cut it using 10-meter intervals. And at range start you have to give, at range end you have to give. Then you press OK and press enter. Now can you see, now it is being cut into 10-meter intervals. Your corridor is cut into 10-meter intervals. Okay, save the drawing. Now it is just a matter of creating the cross sections. Now for that you go to sections, create multiple section views. So select alignment ECL, select sample line, that's all we have. Station range is 0 to this one. Give a section view name S1 and section view style road section, and then next put it as a draft. Okay, use the group plot style this one. Next elevation range, because this is offset range, you don't have to change anything. Later if you want you can change. Elevation range also you have nothing to change. Section display options, here you have to untick this final one. Okay, and then go to press data bands. You can use cross sections. FG elevation is the one that we created. EG elevation should be EG offset, so of course we can use the cross section, the new one. Create section views. Then if I put my cursor somewhere, the cross sections will be created automatically. Now you can see from 10, here you have to change this into, say, the thing is the scale, maybe 150 will be okay, we'll see. Finally you have to change the scale here, right? So, or maybe 1 to 100, I don't know, we'll see what. 1 to 100 is better, it seems. Now can you see, if it is 10, this is your existing road, this is your the this is the widening section and this is the shoulder. Can you see that 5 meter has come like this? And we'll see our, where did we give our super elevation, starting from 35. Okay, we'll go and see 40. 40 here. Can you see that super elevation has changed? Now this is rising. Can you see? 2%. Can you see now? Now can you see the fill there? Although you put it 300 here, what about this fill? After that, what happens? Now see the fill? 4%. Now, please understand that we can't have the perfect cross sections using Civil 3D. Sometimes we'll have to change using AutoCAD tools. Okay. Now, if you want, you can add a, because this is the first time that you visualize your road in the Civil 3D environment. Okay, this is how they come. Once you design it, now you can see here that fill is not enough. Here, this is ABC. Okay, this is ABC. There is no ABC here. So you have to cut the road here. So what you are supposed to do, you will have to raise the profile. If you want to raise the profile, here you can raise and then check what is happening. Now, now what did we cover? We covered uh, surface creation using a point file. Okay, this one we covered. You refer this page number 3 and 9 and 11, and sorry, we created surface creation using a point file. Okay, not CSV format. We went for .txt, but the break line and boundaries are same, right? And don't refer these things because we haven't covered. Horizontal alignment, we did starting alignment in Civil 3D. First element, design a sample curve, right? And compound curve and reverse curve. Transition curves we usually don't use for national roads. We use that only for the expressways, right? And quick profile function we covered. Design centerline labels we covered. Design centerline coordinates we didn't cover. So that we can do now. So that is not a big thing. What you can do is you can go to general tool space and you go to toolbox, and there's reports manager, then alignment. Here incremental stationing report, you can double click it. So it asks what is the profile that you want, so alignment you want. So you have to untick all these things and keep only your design centerline DCL. You select it. Start station and end station is there. Station increment is 10. Now you can click create report. Once you click that, you will get this report here. This is the alignment report. So the station is given, and then northing, easting and tangential direction are given for each and every chainage. Okay, and then super elevation. Super elevation terminology, of course, you will have to refer entering super elevation values using manual method. Now I'll show you how to do super elevation using Super 1000 cc Excel sheet. Okay, that is what we could not cover. Now here I have a macro enabled Excel sheet like this, Super 1000 cc, that was developed by me. So I'll open it. So you have to click this enable content. You have to give some details. Okay, you have to give some details. That is why the RD1, RD2. So the first one is you have to give. Now we'll. Okay, we have to give. Now where are we? Stop share. Share screen. Right, we'll select our DCL alignment. Now it is difficult here. We'll take our alignment. Okay, this is the CSS. So I'll close this. So I'll open our alignment, and then this is our DCL, design center line. You right click it, you go to edit alignment geometry, and then alignment grid view. You go and you right click copy all, and you go to this Super 1000 cc. Okay, and in RD1 sheet you paste everything, right? And then you come back to Civil 3D1. This is okay. And then using general tool space under toolbox, you go to this alignment curve, right? You go to this under alignment, there's alignment curve. You double click this, and here you have to select only the your required alignment. That is only DCL. Don't select any other. Okay, so you have to untick all others. Okay, then press OK. Then you have to save it as civil report. This is the report that was created. Here you have to check any other alignments are there. So alignment ECL is there. No. So you have to control A. You select everything, control C, and then come back to that Super 1000C and go to RD2 and select everything, paste everything. Okay. After that, you go to data and now RD1 is the first report that I got. RD2 is the second report I got. You go to data and put extract data, so it will be extracted. Okay, after that go to design and give the lane width, that is include lane width plus hard shoulder width. So it is 5. Number of lanes per one side is 1. Design speed is 50. There is no uniform LE. Maximum superelevation is 4%. Area type is either it is open or built up. I'll go for open. Begin alignment station is 0. Now you can calculate. If you press the calculate button, please check there are only 4 tabs. Another tab will come with the output. Okay. Now this output, now this is our super elevation we want. We have to save it as file, save as. We have to save as type CSV comma delimited. Okay, CSV comma delimited. So you can give a name like SC, that is super elevation, right? You save it, press OK. Yes. Now close it. That's finished. Now come back to, yeah, shall we open our profile view, because otherwise I can't show that in alignment. Open, I'll open this profile, right? So their super elevation is what we entered. We'll remove that prospector. You go to alignments, sorry, sites, site design, alignments, center line alignment, that is DCL. Go to edit super elevation, tabular editor. If you press this delete, clear all super elevation data, everything will be gone, right? No super elevation. Now what we are going to do is we are going to import the super elevation that we calculated. Here, import super elevation data from file to import. You have to browse. So you go to say SC, press open, press OK, accept all data, remove that, remove this one also, and you can give view region all. Now this is your super elevation. Can you see here? Now it is automatically calculated. Okay, this is calculated using the relevant equation. So we'll check here. It should be 10 meters, right? 63, 73. We got 8 because we did the tactic. Okay, here 121, 130. According to the calculation, it should be 10 meters. Right, now you can see this is a kind of a compound curve, so it is same direction, and you know this is a reverse curve. See how the super elevation is coming. Super elevation changes the direction. Now only you can see. Now I imported this here, that is in the book also, or else you can refer to my the video, then you can see here what I was telling was that here I did a tactic, and I just by looking at the diagram I got this reverse crown, but now the Excel sheet has calculated it. So this difference is 10 meters. Earlier we got 8 meters, you remember, right? And then after that, this is the compound curve. So this is the same direction, super elevation. Now you can see it is turning this way. RHS side should be raised. So R is 2.5, L is minus 2.5. R is 2.5, L is minus 2.5. And here you can see this is a reverse curve, and the super elevation has changed direction at the exact common tangent. Here also super elevation has changed in the exact uh, common direction, common tangent point, right? So everything is done for you, there's nothing you have to do. Okay, but here only in this final curve you have to calculate this side yourself. Okay, that's the only problem we have so far in this Excel sheet. Otherwise, everything is perfectly okay. So it considers here the design speed as 40. Here it considers as, I think this is also 40. Oh, everything it considers. So you don't have to worry. Okay. So I think that will be end of my lecture. And yeah, so that will be end of my lecture.